Hey, hi everyone. Today in this video we'll be discussing about how to set up a single server, and we'll be gradually increasing the server to be getting used by 100 million users as well. So for this is also a kind of a problem statement where this is being a question for multiple interviews as well. So we'll be discussing all the facts which are there implemented for this. Okay, so here as you can see, this is a server, single server, which has been already set up. Okay, this is having the whole database, cache and all in a single server. So if you can go into the flow where a single server, of course we do have a users. Okay, user can be of two types, either he or she, they'll be using the web browser, okay, to contact to the servers, and the second user will be the mobile apps. Okay, so the users are of two types. One is the browser and the second is the mobile app persons. So firstly, user access websites through DNS. Okay, so an IP address is returned to the browser or the mobile app once the IP obtained hypertext transfer protocol, that means HTTP requests are directly sent to the server. Okay, these requests, the IP will be sent directly to the web servers. The web server returns the HTML page or the JSON response for rendering. Okay, so we'll be sending the request, DNS is providing the IP, and then this IP is sent to the web server. Okay, IP is sent to the web server, and then this web server is giving the response of HTML page to the users. So this is how the single server is set up. So depends upon the requirements. This single server can be modified into many things, like if you say how the traffic to the web servers comes from two sources. Okay, so firstly, as I have already told, the mobile applications and the web applications, this is how the traffic will come. These are the users. For the web applications, it uses a combination of server-side languages like Java, Python, etc. to handle business logic, storage, etc. A client-side language, HTML and CSS for the presentation. For the mobile application, HTTP protocol is a communication protocol between the mobile app and the web server. Of course, and the web server. JavaScript object notations, JSON, is commonly used API response format to transfer data due to its simplicity. We'll see an example of how a JSON format will be used for a mobile app to take the response from the servers. Okay, so this is an API response in JSON where we'll be taking the user ID of 12, with the name, first name, the last name, and with the address. Here as you can see, we'll be taking his address, we'll be taking the postal code of the person, and we'll be taking the phone numbers. Okay, if it is a dual SIM number, we'll be taking the numbers of the numbers which are there in the SIM 1. Numbers which are there in the SIM 1. Okay, we'll be taking that as well. So I will be giving, and then number which is there in the SIM 2. Okay, we'll be taking these all requirements to hit for the response from the mobile app. So this is an API JSON where JSON format where we'll be requesting for response in the web server. Okay, so as we have already seen here, we only have a web server which is acting like a database, cache and all, as I have mentioned. To make this compatible with different issues and the problems, what we'll be doing here is we'll be adding a database. Okay, further, whenever this web server gets, to make the web server not loaded with heavy traffic and the response, we'll be adding a database here. Okay, so as you can see the image here, we have added a database to a web server, single web server. Okay, so with the growth of the users, one server is not enough and we need multiple servers, one for the web or mobile traffic and the other for the database. Okay, one is handling the traffic and next one is the database. Separating the both web tier, wherever the web servers are there, that is called as a web tier, and for the database, that is called as a data tier. Okay. So what kind of a databases are there in general? Okay, so we do have two databases. The two databases are relational database and a non-relational database. So major differences between the relational database and the non-relational database are, so as you can see, a relational database, also called a relational database management system, RDBMS, or SQL database. The most popular ones are MySQL, Oracle. So these are the most popular databases, PostgreSQL, etc. Relational databases represents and stores data in tables and rows. Okay, so relational databases represents and stores the data in tables and rows. You can perform join operations using SQL across different database tables. Okay, so here we'll be having the tables where we'll be giving the inputs into the rows sections of a table. Okay, for example, if you do have a table, okay, if you do have a table, we do have different rows and columns. Okay, rows and columns, where let me say if I am going to create a table of college. Okay, if a table of college, what are the things which are needed for the college student are student ID will be there. Okay, we'll be giving that thing using the table format. We'll be giving student ID will be there, student let me explain you here. So for the tables, relational database, student ID will be there. Okay, student name will be there, student surname will be there. Okay, student joining date will be there. So likewise, different rows and columns will be there for a table. These will be there for the relational database, where we will be representing and storing the data in tables and rows format. Okay, for the non-relational databases are also called as NoSQL databases. NoSQL databases. Popular ones are CouchDB, Neo4j, Cassandra, HBase, Amazon DynamoDB, etc. So these databases are grouped into 4 categories, as we already had seen in the previous videos as well. We have been used the key value stores for designing the chart system as well. So these are the 4 categories where we have a key value stores, graph stores, column stores, and the document stores. Join operations are generally not supported in non-relational databases, but it's up to you, whatever the database, what is the requirement to you, it depends upon the requirement, you can take the databases. Okay, so as you can see, we have for the single web server, we have added a web tier, we have segregated the web tier, and along with that we have segregated the data tier. Okay, these are having only single in quantity. Okay, for the things, if you want, if this web server, we have only one, right? So if this web server gets crashed, so the users will face a bad experience to not they will be not able to access the content, right? So for that reason, what we'll be doing is we'll be scaling the servers. Okay, so there are 2 types of scaling things. One is the vertical server. Okay, as you can see, vertical scaling is there, and along with that horizontal scaling is there. Okay, vertical scaling is, for a server, we will be increasing the CPU, RAM and disk. Okay, if a server is having a 2 GB of RAM and a storage of 1 TB, okay, and a storage of 1 TB, we'll be increasing this using vertical scaling. We'll be increasing this to a 4 GB. I mean, it's up to you only, it's an optional thing. 4 GB of RAM, will be increasing 10 TB of disk space, and for this go on as per the increment which you people keep. Okay, so this, if we are increasing the CPU, RAM and the disk, I mean the space storage, this is called as a vertical scaling. And of course this is having a limit. Okay, this is having a limit which is of 1024 GB. Okay, so after this vertical scaling we do have a horizontal scaling. Okay, here what we can do is, instead of increasing the requirements into the server, into the same server, we will be replicating the servers into many. Okay, we can add the more servers. So this is the main difference between vertical scaling and the horizontal scaling. Here we can add the performance, we can add as per the performance. Here we can add the servers. Okay, so basically, so as you can see, the single server is there. Okay, for a single database, so we'll be adding different servers. Okay, let's say, so yeah, let's say, okay, I think I have already, okay, let me erase this thing. So, okay, yeah, if you can see, as I have told you, I have did a horizontal scaling and I have added a web server. Okay, web server here. Along this server 1, I have added a server 2. Okay, for a user, okay, who is requesting for a response, these two web servers are there in the web tier. Okay, and they are unknown for which server this request will get hit from the user. To keep that issue in mind, we will be adding a load balancer here. Okay, we'll be adding a load balancer. With this load balancer, let me say, the request will get deviated to the servers which is having a low load. Okay, let me explain you here. So what is a load balancer? So a load balancer evenly distributes incoming traffic among web servers that are defined in a load balance set. Okay, basically the users connect to the public IP of the load balancer directly. With this setup, web servers are unreachable directly by clients anywhere. For better security, private IPs, okay, private IPs are used for communication between servers. A private IP is an IP address reachable only between the servers which are having the same network, which are there in the same network. So let me let me go in brief. So a user will be contacting the DNS for the IP. Okay, the IP will come and hit to the load balancer, and this load balancer will convert the public IP into the different private IPs, and these private IPs will directly communicate with the servers. Okay, these private IPs will directly communicate with the servers. If the server 2 is busy, this private IP will directly hit to the server 1, and this is the responsibility which the load balancer is doing. Depends upon the load and performance responses, this will enroute the response to a particular server. Okay, so now the web tier, as you can see, the web tier looks good. What about the data tier? The currently, of course this is not the image, or else let me draw you. I think let me draw you here. So we'll be having one data, okay, DB here. Okay, so now this is looking very good. We do have different servers in the web tier, but we only have one database in the data tier. So this will cause us, what if the database gets crashed? Okay, this is one problem. So to fix this, what we will be doing is, we will be doing a functionality called data replications. Okay, so what is a data replication? So a master database generally only supports write operations. A slave database gets copies of data from the master database. As you can see, the master database, okay, so master database only supports read operations. All the data modifying commands like insert, delete or update must be sent to the master database. Most applications require a much higher ratio of read to write, thus the number of slave database in a system is usually larger than the number of master databases. Okay, as you can see, for a web tier, from a web tier a request is sent to the database, I mean the data tier. Okay, here let me tell you, I have just given the example. Here we will be having users. Okay, we will be having users who is requesting for the DNS, and this IP will be hit back to the servers, web servers. So this is horizontal scaling. Horizontal scaling is here. Okay, of course the load balancer is also there. So user using load balancer will hit the web server, and this web server, from the web server, whatever the write operations are there, write operations, insert operations, updation operations are there, will be redirected to the master database, and to the operations which are needed to read only will be directed to the slave databases. Okay, so this is how a data replication functionality will be done. Okay, so this is how the diagram will look like as I have drawn here. So this is how a user will have a load balancer. The request will be sent to the servers who is having, I mean, who are free and take the response. Okay, and the write operations will write, insert, I mean along with the write, insert, updation and etc. operations will be done in the master database. Apart from those updates, only read operations will be there into the slave database. Okay, so this is how the structure will look like, where we have already been used a load balancer, we have used the scaling in the web tier, and we have used the data replication in the data tier. Okay, so what if the response time and the load balance gets a very bad experience? Okay, so now as we have seen, we have a solid understanding of the web and data types. It is time to improve the load and response time. This can be done by adding a cache layer. And shifting the static content like images, CSS, video files and all to the content network delivery. Okay, content delivery network. Okay, so as you can see, as I have already told, we do have a cache for every different devices, right? So what is the use of a cache? I mean, most of the people do know that cache will help to easily fetch the data. Okay, cache. So for the network setups as well, we do have a cache, which is a temporary storage area that stores the results of expensive responses or frequently accessed data in memory, so that subsequent requests are served more quickly. Okay, what if a cache, I mean, let me explain you. I mean, we have already had implemented the cache here, but what is the functionality which are being driven into the cache are, whenever a data exists, I mean, whenever a data has requested through the cache, let me say, if we do have a web server, right? If data exists in cache, we'll read from cache whatever the response a web server is asking. Let me say I'm asking for a website. Okay, I'm asking for a website which have been already stored into my cache. That will easily fetch from the cache layer to the response of the user. Okay, what if I am planning to open a very new website which I have not yet till opened the browser or the mobile app? Okay, this what we'll be doing is we'll be hitting that response to the database, and then after getting the response from the DB, we'll be storing that file to the cache, and then we'll be returning back to the web servers. Okay, so hope you understood that what we'll be doing here is, let me say I am now opening Netflix. Okay, I have been already opened Netflix many times. Okay, these Netflix website details will be there in the cache. Okay, whenever I do open the mobile browser, okay, desktop browser, Chrome or anything, Mozilla, so depends upon the server's cache will be read, and then it will hit back to the user. This is one thing. Okay, this is how the cache will work. What if I haven't opened any website till now, like Amazon? Okay, I'm now opening a website which I haven't opened till now into the workstation which I'm working. Okay, so for Amazon, what servers will do here is the user will send the response request. This is how this will go to the load balancer and then to the servers, and then this will move to the database. From the database, it will return back to the cache, and along with that cache, it will go back to the users. Okay, so while going back to the users response, it will store the data in the cache as well. So problem. So for the servers which are far away, the response and the request time will be very bad. Okay, so what if we do have a servers in the US and now we want to access it in India? Let's say as we have already taken the example of Netflix, let's continue with that. So Netflix servers are there in the USA, as we already knew. So I want to access that in the India. So but the response time to access that content, and I mean the request from here to there and the response from there to here will be I mean that will be not the prompt time. Okay, sometimes the users will do have a, I mean there will be a load over that for the accessing, right? So requests and response to, I mean the response and request time, to keeping that in mind, what we will be doing here if the distance is too far. Okay, we will be using CDNs. Okay, CDNs. What is a CDN? Content delivery network. We'll be using content delivery network. So a content delivery network of a geographical dispersed servers used to deliver static content. CDN server caches static contents like images, videos, CSS, JavaScript files, and etc. So the users from any region, as per the regions, we will be setting the CDNs. Let's say the server is there in the USA and user is there in India. Okay, what we will be doing here is we will be setting a geo-routed CDN in the nearest regions. Okay, so a CDN is there set up in India. Okay, let's say in India we have a CDN. So what will be the use of CDNs is, as I have already told, this will be storing the details of images, videos, JavaScripts and all. So this request for opening the Netflix will be moved to the CDN, and then this will get back to the users. This is how the CDN will do work like. So here, as you can see, a client from the US, a client from the India. Okay, I hope this is visible to you. This is client 1 and client 2. Client 1 and client 2. So whatever the nearest CDN is there, okay, content delivery network is there, geographically dispersed server. As you can see here, this is called as we can call it as a geo-routed servers as well. So geographically dispersed servers, the nearest servers will hit back the response. Okay, hit backs the response to the client. So the USA person and the India person are asking for a response using to the CDN. So whatever the nearest CDN is there, it will respond back to the client, I mean the users. Okay, so it is there 40 meters away for the client, so this will hit back to the user for the content. Or else if this is having an issue to deliver, or the load is there, so the next nearest CDN will respond, depends upon the origins. Okay, so we just need to set up different CDNs in the different origins. This is how it will work, or else we'll be facing some kind of a failure issues as well. So let me explain you how this CDN will do work. Okay, so Hope this is visible to you guys. I think this time these videos images are having less quality. We'll see in next videos to not get this kind of a problem. So let's say user A and user B are there. Okay, let's say a user A and user B are there. Okay, so what we'll be doing is we are trying to get an image. Okay, we are trying to get an image. Let me say I want my image, profile image. Okay, or else let me say let me say okay, user 1 wants to get an image. What CDN is doing is CDN will see whatever the image which I have asked for, is it there in that CDN or not. If it is there in that CDN, it will hit back the image to the users as a response, or else what a CDN is doing is it is forwarding that same request, okay, to the servers and getting back the request. I mean, after sending the request to the servers from the database, and the flow will do floats, okay, from servers to database and all. So from the servers, this image will store into the CDN again. Okay, whatever the response we got for the image which is not there in the CDN will get back to the get back to the CDN from the server, and then this will store into the CDN. Okay, and along with this it will again return back to the image. This is how the CDN will work. If there is an image already there, let's say if A is an image which is already there in the CDN, and B is an image which is not there in the CDN. Okay, let's an example I'll be telling. So user A is asking for an image of A which is already there in the image. It will request for the image A. Okay, and this image will return back, because it is already there in the CDN. It will return back to the user within fraction of seconds, because it is already there. What if, as I have told you, B is not there in the image, not there in the CDN. So B image, to get the B image in the CDN, what it will do, the CDN will do is it will ask for a request to the server and then stores the content of B in the CDN and then hit back to the user A. For the next users which are already being searching for the same A and B images, already CDN is having the image stored, right? So this stored image will easily redirect to the user B. So these whole things will do have a TTL. Okay, a CDN will have a TTL, okay, time to live. So let's say the origin returns image to the CDN server, which includes optional HTTP header timeline to live, which describes how long the image is cached. Okay, the CDN catches the images and returns it to the user A. The image remains cached on in the CDN until the TTL expires. So this is how. But the user B sends the sends a request to get the same image of the image which is already been asked for the user A. So these images from the cache, as long as the TTL is not expired, will be hit back to the user A. Okay, so basically, so static assets, JavaScript, CSS, images, etc. are no longer served by the web servers. They are fetched from the CDN for better performance. The database load is highlighted by the caching data. So as you can see here, so DNS will be getting the IP, and then load balancers is using to balance the load, and the different servers from the web tier to fetch the I mean, this will segregate the response time as well, request and response time, the master data. Along with that, we'll be having the cache. Okay, so as I have already told you, cache is there and CDN is also there. So before going on to that, before going on to the cache and all, let's say let's say yeah, so CDN as we are in the CDN, content delivery network. So there are some couple of operations which are also being used in the CDN. So let's briefly describe about those. So let's say CDN services are mostly used in Netflix. Okay, so mostly we will be using these kind of services in the Netflix, Amazon and all, where a master data is having the content and the people over the overall world will be accessing the data. Okay, so this kind of a server setup is used for the OTT kind of a platforms. Okay, what if we are going to implement this same kind of a setup in for the chat platforms like WhatsApp, Instagram and all, because this this is there only for the OTT kind of platforms only, where we'll be having the master and the slaves with the CDNs. But for the section kind of apps like WhatsApp, Instagram and all will not suitable for these things. Why? Because let me give you in brief. It means whenever you request for a post on Instagram, it first checks whether you are logged into your account. This session data has to be stored somewhere temporarily as long as the session is still active. If we store session data inside one of the servers, then the data would be lost. If the particular server is crashed, let me tell you, let's say let's say, for your understanding, I'm just removing this thing for now. So what I'll be telling you is, for a session storage, okay, session storage, for a session storage apps like Netflix, WhatsApp, what is required is will be requiring in first priority is their logins. Okay, so to keep these sessions into one single server, okay, as we have already told, the web tier, in the web tier, if you say this is a web tier, we can't keep a session into a single server. Like say, if I had a, let me say, I have asked for a session. Okay, I have asked for a session, and this session will goes here, web server, and what session storage will be doing is, it will be stays there till the session gets closed. Okay, this is how the session will work. So if we are keeping these sessions to be stored into a server, into the horizontal scaling, into server 1, 2, 3 and then, okay, if you are keeping this single server storage into the singles, let me say this, if you are keeping this session storage in a single server, what happens is, if this server gets shut down, this session will get closed. Okay, and this server which is having the session storage will not be able to respond for the different servers which are there in the same network. Okay, to keeping this in mind, what we will be doing here is, okay, we are adding a session. As you can see, NoSQL, we do call it as a NoSQL. We will be adding a session storage DB outside of the tiers. Okay, outside of the tiers, where which is called as a data center outside of the tiers. Okay, which will record the sessions. Okay, which will record the sessions apart from this all servers. Okay, so as you can see, along with this, I mean, we do have the session storages as well. So generally, NoSQL database is preferred because it is easier to scale. Okay, it is easier to scale NoSQL. So like MongoDB, CouchDB is there. Okay, now whenever we create such a large scale system, we don't just want to process requests for users, we also want to monitor and log in informations, right, about what failed, I mean how many failed requests are there. We completely need the activity logo here, right? So to keep those all in mind and to track those things with the peak hours, and we want to monitor all the activities which are been there running into the data centers. So what we will be doing here is we will be using the messaging queue technique, where we will be having a producer. Okay, where we will be having a producer. Okay, a producer will tell, I mean he will send the messages in queue. Okay, and a consumer. Okay, and a consumer who will process these messages which were queued by the producers. So this is how the messaging queue technique will be done, and most of the data centers will also have this complete setup. So, and next is, as you can see, we have already implemented a high level. Okay, we have already implemented a high level server setup. Let's say this is in Japan. Okay, let's say this data center is there in Japan. And what if this data center gets shut down? So there will be no response from their end. We will be facing different kind of issues to not able to access the content. Okay, to keeping this in mind, what we will be doing is we will be adding the same data center setups in different regions. Okay, we will be replicating this complete data center setup. Okay, completely data center setup in India as well. Okay, let's say in India, I mean India we have added, and then we will be adding that same in the USA as well. Okay, USA as well. And this load balancer, okay, if the Japan server data center is not responding to take the request, okay, the load balancer will give request to the nearest data center. Let's say India, I have I mean the load balancer has given the request to India. Again, if India is not responding, this load balancer will give request to the USA. So this is how we can set up the servers from a single user setup to 100 or millions of users setup. Okay, so hope this video is worth for the interview preparations, and we'll be looking for the next videos to be done. Okay, thank you.